Hello and welcome to my channel Econ Academy. In this tutorial I will show you how to estimate panel ARDL and how to interpret it using Stata. So do like the video and subscribe to my channel. First of all, um, in estimating ARDL panel ARDL model in Stata, we have three estimators. One is pooled mean group, and the second is which is also called PMG, and the second is mean group, which is also called MG, and the third is dynamic fixed effects, which is also called DFE. For more information about these estimator, you can check it through Google. Here I cannot tell you because the video will be very long then. So here I will only show you how to estimate these three and how to make decision on based on Hausman test, and that which estimator we will use in our estimation. So first of all, I have already imported panel data in my Stata. For this you can watch my video on how to import panel data into Stata. So if you haven't know how to install how to import panel data, then you can watch that video. We will start directly. So in the command section, first of all we will install the command for these three estimators, and the command for installing anything in Stata is ssc and in space install, INSTALL. So if you want to install any command in Stata, then you have to give that command to Stata, ssc and install, and then you will write the name of that code which you want to install. So I want to install xtpmg comma replace, replace. So I want to install this command, therefore I have written it. So the whole command will be ssc space install space xtpmg comma replace, and will press enter. You must have internet for installing this. I have already installed it, so this is why Stata give me that all files already exist and are up to date. Now we can start estimation. For this we will write the command xtpmg, and then with the d dot is used for difference, and then the name of the dependent variable, which is g in this case, and then d dot ep, which is the name of the independent variable, and then d dot ip, which is the name of the another independent variable. So this d dot and the third d dot is used for difference, because we want to estimate short run equation. So this equation will give us short run results, and after comma we will write LR for long run, and in the bracket we will write L dot G, which is first period lag of the dependent variable, and then EP, which is independent variable, and then another IP, which is another independent variable, and bracket close. And now we will write replace PMG. So this command will give estimation based on PMG estimator. So this whole command is used for PMG estimator. Then we will press enter. It will took some data because some time, because my data is quite large. So it is doing estimation. About 1 minute it will take. After 3 to 4 after 4 or 5 iteration, it will give us results. So you can see that this is the command which we have given, and these are the iteration just Stata do to make best results. And this number of observation, you can see that is 699 is the number of observation, which is quite high. And this is the country identifier, and this is time identifier, and this is number of countries and number of years. And these are the result of the long run, while these are the result of the short runs. We will interpret it later, but first of all we have to choose which we have to check that which estimator is best for estimation. So we will give the same command again with some modification, that is xtpmg and d.g space d.ep space d.ip comma lr, which is used for long run, and l.g first period lag of government spending, sorry, for growth, which is dependent variable, and then ep and ip are the independent variables, and bracket close. And now after replace, we will write mg instead of pg. So the whole command is the same. Instead of only mg is replaced by pg. So this is how we will estimate mg estimator. So then we will press enter. It will also take some time. So you can see that this is the command which we have given, and these are the results. These are the long run results, while these are the short run results. Now we will check which method between these two PMG and MG we will use. For this we have a command houseman PMG space MG comma sigma more. So this is the command which we will use, and this command will give us estimation based on houseman test to and decide. We will decide based on this houseman test that which estimator we will use between these two. We will press enter now. So this is the command which we have given, and it is a command for houseman test to decide between PMG and MG, and the decision we will make based on this probability of chi-square. So if this probability of chi-square is below 0.05 or below 5%, then we will use mg. Otherwise, if this probability is 5 or above 5% or above 5%, then we will use pmg. Or in other words, we can say that if this probability is 0.05 or above 0.05, then we will use pmg. So in this case, this probability is above 0.05 or above 5%, so we will use PMG estimator in this specific case. So our model estimation will be till this point, but just in this case, because the probability is above 0.05, and we will then estimate the same PMG estimator, that is xtpmg d dot g and d dot ep and d dot ip and comma lr L dot G EP and IP and replace. And after replace command, as according to this Houseman test, we should use PMG estimator because the probability of chi-square is above 0.05, so we will write PMG after replace, and we will press enter. Same, it will take a bit time. So now just in this case, because the probability of chi-square is above 0.05, we have used an PMG, and we will estimate these results. So these will be the long run results, and these all will be the short run results. But the goal of this video is not to run an ARDL model, but just to give you information about how these three estimators run and how to take decision between these three estimators. So just for this case, um, if we have a probability of chi-square in that Houseman test above 0.05 or above 5%, then we will use that PMG estimator, and we cannot use MG or DFE estimator. But let's suppose we have this probability below 0.05 or below 5 or below 5%. Just suppose that, because we want to move forward to give you information about how these MG and DFE estimator run, and how to choose between these two as well. So now we are supposing that the probability of chi-square in the Houseman test between PMG and MG is below 0.05 or below 5%. So then we have to move forward, and we will run XTPMG model, XTMG MG model again, that is mean group model again. So for this we will run again XTPMG. We can run the same command from here, that is xtpmg d.g d.ep d.ip and comma lr l.g ep and ip and replace, and now we will run mg command. So we will remove p from that, and we will press enter, and we will also run DFE estimator as well. So again we will give the same command xtpng d.g d.ep d.ip comma lr and l.g ep ip and replace. And after replace, now we will use DFE estimator. So first we will we have run PMG estimator, so we have written here PMG after replace, and then we have run MG command. So we have written MG here, and now we are running dynamic fixed effect estimator. So we have written DFE, and we will press enter. So this is how to choose between MG and DFE. We will first run the MG estimator, and then we will run DFE estimator, and now we will run the same Houseman test, that is Houseman test between between MG and DFE. So we will write Houseman, and we will write MG, and we will write DFE in capital letter because Stata is case sensitive, and after comma we will write sigma more. So It is the same Houseman test, but instead of PMG and MG, we have written MG and DFE. But remember to write DFE in capital letters because Stata is case sensitive in this case. So then we will press enter. So there is no probability of chi-square because this chi-square value must be above 0, or this chi-square value must be positive, so indicating the same that we should use PMG estimator, as this Houseman test is not valid because the first Houseman test gives us information that we should use PMG, not MG or DFE. But just for your understanding, if there is probability of chi-square, if this value is positive, and in the first case the probability of chi-square is below 0.05, then we should move forward, and after moving forward we will come here, and if this probability of chi-square is positive, and here the here will be the probability of if this value of chi-square is positive, then there will be the probability of chi-square, and we will make decision based on that probability of chi-square, that whether we should use MG or DFE. So if that probability, which is not here now, but if let's suppose if there is a probability of chi-square, then we will decide based on these two that if this probability of chi-square is above 0.05 or above 5%, then we will use a DFE, which is dynamic fixed effect, and if this probability of chi-square is below 0.05 or below 5%, then we will use MG. So this is how to decide between PMG, MG, and DFE. Now our estimation result shows us that we should use PMG estimator. So now we will use PMG estimator and we will interpret it. So again, using the same PMG estimator, this is the PMG estimator which we have estimated earlier, that the command is xtpmg d.g d.ep d.ip comma lr l.g ep ip and replace PMG. d.g is the dependent variable, and these two are the independent variables indicating the results of short run, and this lr is the indicating the result of long run, and l.g is the lag of the one period lag of the dependent variable, and these two are the independent variables. And after replace, we have written PMG, indicating that we are using PMG estimator, so as suggested by Houseman test. Now we will press enter. It will take a bit time. Now this is the result which we should interpret. We have made decision based on Houseman test that we should use PMG estimator. So this is a command which we have given, and this is the log likelihood which we should interpret in our estimation results. So we will say that the log likelihood of our estimator is minus 122.93, and these are the number of observation, and the number of group is the number of cross sections, which is also, we can say that, number of countries, and this is the number of time period, and these are the result of the long run, and these are the result of the short run. So we will check the same we will check the first first of all we will check the significance of a variable, and then through probability and through z-stat, and then we will interpret its coefficient. If the variable is significant, then we will interpret its coefficient. Otherwise we will say that this variable is insignificant, so this variable is insignificant, and this variable have insignificant impact on that dependent variable. So first of all we will interpret the result of, we can interpret the result of anyone between the long run or short run. Let's suppose we first of all interpret the result of long run. So this is the result of these are the result of the long run. So first of all we will interpret it. So for interpreting it, first of all we will check its probability. So this is the EP is government spending, so we will interpret it as if we will check its significance in the probability. If the probability value is below 0.05 or below 5%, then we will say that this variable is significant. Otherwise, if the probability is 0.05 or above 0.05, or we can say that 5% or above 5%, then we will say that this variable is insignificant. So you can see that the probability value of EP, which is government spending, is 0 or 0%, which is below 0.05 or below 5%. So this variable is significant, and we can check its significance through z-stat as well. If the z-stat is 2 or above 2 in absolute form, then we will say that this variable is significant. Otherwise we will say that this variable is insignificant. And this is investment, this IP is investment, so the probability of IP is above 0.05 or above 5%, and which is 17%. So we will say that this variable is insignificant. The government spending variable, that is EP, is significant because its probability value is below 0.05 and its z-stat value is about 2% in absolute about 2 in absolute form. And the investment, which is IP, is insignificant because its probability value is above 0.05 or above 5%, and its z-stat is below 2 in absolute form. So now we will interpret the coefficients. We will interpret only the coefficient of EP because IP is insignificant. So this negative, we will also interpret this negative sign with the coefficient. So this coefficient is minus 0.40, indicating that if the probability, if the indicating that if we increase government spending, as EP is government spending, so then the dependent variable, which is GDP growth, will be decreased by 0.4%. Again, I am interpreting it because it might be a bit confusing. As EP is a government spending and a G, which is the dependent variable, is GDP growth, so we can say that if the government spending increased by 1%, then the GDP will be decreased by 0.4% because of that minus sign. So we will say that GDP will be decreased by 0.4%. Or in another sense, we can say that if the values are not in log form or not in percentage form, then we will say that if the government spending increased by 1, then the GDP will be decreased by 0.4% in the long run. We should mention in the long run as well in that case. because these are the result of long run. So we will say that if the probability, if the government spending increased by 1%, then the GDP will be decreased by 0.4% in the long run. Or we can say that if the government spending increased by 1, then the GDP will be decreased by 0.4%, 0.4 in the long run. So this is how we will interpret the long run results, and we will not interpret the coefficient of the investment because it is insignificant. Now we will interpret these two short run results as well, because this is the government spending, and this is investment. So first of all, we will check the same probability. If the probability is below 0.05 or below 5%, then we will say that this variable is significant, and if the probability is above 0.05 or above 5%, then we will say that this variable is insignificant. So in this case, the probability of EP is 0% or below, or 0, which is below 0.05 or below 0.0 or below 5%. So we will say that this variable is significant. The same is the case with the z-stat. The value of z-stat is about 2 in absolute form, so we will say that this variable is significant. We can check any one between z-stat and the probability of z-stat. Anyone will be okay. Now, as this variable is significant, so we will also interpret its coefficient. Now you can see that the coefficient of EP is changed from that in the short run from the long run. So in the short run, the coefficient of EP, as EP is government spending and GDP is and G is the GDP growth, and EP is independent variable and G is dependent variable. So we will interpret the coefficient of EP as if we increased government spending by 1%, then the as there is negative sign, then the GDP growth will be decreased by 1.32%. Or in another sense, in the short run, we will also say in the short run. So again, I am interpreting it if we increase government spending by 1%, then GDP will be decreased by 1.32% in the short run. Or in another sense, we can also say that if if government spending increased by 1%, if government spending increased by 1, then the GDP will be decreased by 1.32 in the short run. This is how we will interpret this government spending. Now we will check the coefficient of investment. Now we will check the significance of investment. That is IP. So you can see that the coefficient probability value of investment is 0% or 0, which is below 0.05 or below 5%. So we will say that this variable is significant, and same is the case of z-stat, as if this probability value of as if the z-stat is 2 or about 2 in absolute form, then we will say that this specific variable is significant. So now we will interpret this coefficient as well, because in the long run this variable is insignificant, while in the short run this variable is significant. So this is significant. We will interpret its coefficient as well. Again, IP is investment and G is GDP growth, and IP is independent variable and GDP growth is the dependent variable. So we will say that as the coefficient is 0.46 and with no sign, so it indicating that it has a positive impact on the dependent variable. So we will say that if investment increased by 1%, then the GDP growth will be increased by 0.46% in the short run. Or if the variables is not in the percentage form, then we will say that if IP is increased by 1, then GDP will be increased by 0.46 in the short run. So this is how we will run an ARDL model, and how this is how we will make decision based on how which estimator to use, whether PMG, MG, or DFE. So I think you will understand it, and so do like the video and subscribe to my channel. So bye for now, see you in the next video.